Good morning, children. Hope you all are safe. Welcome to the second part of algebraic expressions and identities. Last session we have learned the addition and subtraction of algebraic expressions. Today, let us start with the multiplication of algebraic expressions. While multiplying the algebraic expressions, we have to keep the following rules in mind. We have already learned that when you multiply two numbers with the like signs, the answer is positive, and the product of two numbers with unlike sign is negative. It means positive into positive gives us positive, negative into negative, the answer is a positive one, and the product of a positive and a negative number is a negative number. We have the second rule like this. If a is any variable and m and n are integers, then a raised to m into a raised to n equals a raised to m plus n. Keep these two rules in the mind. Now, let's go in detail about the multiplication of algebraic expressions. First, let us see how to multiply two monomials. Of course, what is a monomial? It is a one-term expression. Don't you remember that? Let us see here with an example. Here, the first monomial is 9 x raised to 6 y raised to 7. The second monomial is 10 x raised to 5 y raised to 3. That means here we are multiplying two monomials. In order to multiply two monomials, the rule is you have to multiply the coefficient. Coefficient means the number part which is given. That is the coefficient part. Then, secondly, we have to multiply the variable using the product rule of exponents. So here we can see the numbers or the coefficients are 9 into 10. Instead of keeping the multiplication symbol, we can keep a dot also to show the multiplication. That's why here it is kept as a dot. So we read it as 9 into 10. It is grouped together. The number part is grouped together. Now the variable part is grouped together. That is x raised to 6, y raised to 7, x raised to 5, y raised to 3. Now, as we know from the product rule of exponents, we have to group the variables with the same base. Okay, that means we group x variables together, we group y variables together. So the next step is like that. We will be grouping the x terms together. It is shown with the same color. Both the x terms are shown with the same color and the y terms are shown with the different color. Both the y terms are also shown with a different color. X terms in one color and y terms in another color. Now, we know that when the base remains the same, to find the product, we have to add the exponent. So here, the exponent of x has got the power as 6 and 5, and y's power is 7 and 3. So, x raised to 6 into x raised to 5 is equal to x raised to 6 plus 5, and y raised to 7 into y raised to 3 equals y raised to 7 plus 3, that is y raised to 10. So let us see how we have done it one more time. We group the numbers together. We multiply the number part that we call here as coefficient. Then in the second stage, we group the x variables together and we group the y variables together, so that we will be doing the same variables terms together and adding the exponents. So that's how we get the answer as 90 x raised to 11 y raised to 10. So the product of two monomial, that is 9 x raised to 6 y raised to 7 into 10 x raised to 5 y raised to 3 gives us the answer 90 x raised to 11 y raised to 10, which is again a monomial. Here we discuss the case of multiplying two monomials. Now let us see here with some examples. Okay, here also, as you see, the first question, 4 a raised to 9 b raised to 3 multiplied with 2 a raised to 4 b. As I said before, you multiply 4 into 2, which gives you 8. A base we have taken and we add 9 and 4, which gives the answer 13. With the base b and adding 3 and 1 gives us b raised to 4. So the final answer is 8 a raised to 13 b raised to 4. Second question, 7 w raised to 2 y raised to 5 10 w raised to 10 y raised to 2. That's same as 7 into 10. The answer is 70. W's power we have added 2 plus 10, which gives us 12, and y's power 5 and 2 added gives us the answer 7. So the final answer is 70 w raised to 12 y raised to 7. Third question, 2 r t raised to 3 into minus 3 r raised to 5. The product of 2 into minus 3 gives us minus 6. R raised to 1 and R raised to 5. When you multiply, it is R raised to 6. Then T raised to 3 alone is there. There is no other T terms. So it remains as T raised to 3 itself. Now we move on to the fourth question. That is 3 K raised to 5 M n raised to 4 into 7 k raised to 3 m raised to 3 n raised to 3. The product of the coefficient 3 and 7 gives us 21. K, when you add the powers 5 and 3, it is k raised to 8. M raised to the power 1 plus 3 gives us m raised to 4. The product of n raised to 4 and n raised to 3, that is n raised to 4 plus 3 gives us n raised to 7. Fifth question, 12 x raised to 2 y raised to 3 into 2 x y raised to 2. Here we multiply the number 12 into 2 gives us 24. Then x raised to 2 into x is equal to x raised to 2 plus 1, that is x raised to 3. Then y raised to 3 into y raised to 2, that is equal to y raised to 3 plus 2, which gives us y raised to 5. When you see all of this, what we have done here, the question is a mixture of different variables, but we add only the power of like variables. Keep that also in the mind. Now here they have shown with 3 of the monomials. The same rule is applicable when 3 monomials also come. We multiply the number part, keep it as a coefficient, group the variables part together, and we use the laws of exponents. Let us see. The question, minus 5 x raised to 2 into 6 x raised to 10 into minus x. Taking the coefficient part, the product is minus 5 into 6 into minus 1. And taking the x part, x raised to 2 into x raised to 10 into x raised to 1. The product of negative 5 into positive 6 is negative 30. The negative 30 multiplied with negative 1 gives us 30. X raised to 2 into x raised to 10 into x raised to 1. We apply the product rule of exponents. It is x raised to 2 plus 10 plus 1. That is x raised to 13 come. So the final answer is 30 x raised to 13. Hope that you are clear with the multiplication of monomials. Now let us continue with the multiplication of monomials, but this is the second case. Here you have to find the area of the following rectangle. As you see the rectangle here, the length is 5y squared and the breadth of the rectangle is 3y cubed. We know that the area of rectangle equals length into breadth. So that is equal to 5y squared into 3y cubed. The product of 5 and 3 is 15. Then y squared into y cubed gives us y raised to 5. Now, shall we solve some questions? Here are a few questions for you to try. Find the product. The first question, minus 6 a squared b into minus 7 ab. Second one, 7xyz squared by 9 into 27xy squared by 35 into y squared z raised to 5 by 3. Third question, simplify the expression 4x squared y into 2y squared into 3x raised to 4 and evaluate when x is equal to minus 1 and y is equal to 2. Do it and you can check the answers. The first question's answer is 42a cubed b squared. Second question, the answer is 1 by 5 x raised to 2 into y raised to 5 into z raised to 7. And the third one, when you simplify the expression, it is 24 x raised to 6 y raised to 3. And the value of the expression, when you substitute x equals minus 1 and y equals 2, is 192. Hope that you got the correct answer. Let us think about the other different cases of multiplying the monomials. The second case is multiplying a monomial by a binomial. As you know, monomial is a one-term expression and a binomial is a two-term expression. The question given here is 2x cubed into 3x plus 2y. Here 2x cubed is the monomial and 3x plus 2y is the binomial. Here we apply the distributive law. We already know a into b plus c equals a into b plus a into c. So the same rule we apply here. So 2x cubed into 3x plus 2x cubed into 2y. As we have learned in the case of monomial multiplication, we multiply the number part, that is the coefficient part, and we use the rules of exponents for the variable part. So 2 into 3 gives us 6. Then x raised to 3 into x is equal to x raised to 3 plus 1, that is x raised to 4. Then 2x cubed into 2y. Here the product of the number part, that is 2 into 2 gives us 4. and x cube alone is there, y alone is there. So that is 4x cube y. Here the final answer is written as 6x raised to 4 plus 4x cube y. The answer here we got is a binomial. We have multiplied a monomial by a binomial here. Now we can extend the same rule for multiplying a monomial by any of the polynomials. Now let us see the case of a monomial by a trinomial. Here the monomial is 3a and the trinomial is 2a squared plus 4ab squared minus 5ab. It is just an extension of the previous law. So we multiply 3a into 2a squared, which gives us 6a cubed. Again we multiplied the 3a with the second term 4ab squared, which gives us 12a squared b squared. The 3a multiplied with the third term, that is minus 5ab, gives us the answer minus 15a squared b. So here we have discussed the multiplication of the monomial with a binomial and also the multiplication of a monomial by a trinomial. Let us try these questions. First one, 3 into x squared plus 2x plus 6. Second one, 2 into x squared minus x plus 11. Third one, minus 3x into x squared minus 7x plus 1. Last one, 5x into minus 2x squared plus 8x plus 12. Here you can check the answers. First one answer is 3x squared plus 6x plus 18. Second one, 2x squared minus 2x plus 22. Third answer is minus 3x cubed plus 21x squared minus 3x. Fourth one, minus 10x cubed plus 40x squared plus 60x. So today we have learned the multiplication of monomials in 3 different cases. The first one was monomial with a monomial. Case 2, monomial with a binomial. And case 3, monomial with a trinomial. Hope that you understood this. In the next section, we will be continuing with the multiplication of polynomials. That's all for today. When the world says give up, hope whispers, try it one more. Thank you, children. Have a great day.